Welcome, everyone, and thank you for joining day 3 of Qtric's Low Carbon Smart Mobility Technology Conference. And I am excited to welcome you to today's panel called Retrofits, a viable solution for transit agencies looking to transition to zero-emission buses. My name is Adriana Xu Yin, and I'm the Digital Business Development Lead with Qtric. Before we get started, as part of our commitment to gender parity in transit, we are running a national survey to assess gender disparity. In the Canadian transit industry, research clearly shows there is a stark difference between the number of women in senior leadership positions compared to men. We know these disparities exist, but we are less clear on why these disparities continue to persist. At Qtric, one of the ways in which we have committed to gender and racial equity has translated into a research partnership with the University of Windsor. This has allowed us to engage in learning more about the complexities of the workplace environment. To increase the number of women in senior leadership positions, we need to understand the experiences of all individuals with different identities who are currently working in transit, so we can make informed recommendations to transit organizations about the best practices, policy, and strategy. Today, we invite you to complete a short online survey to learn more about the social and organizational context that you work in. The survey is open to anyone in any role who works in the transit industry in Canada. It is anonymous, so we do not ask for your name or your organization. We will be sharing back the findings of our research in the fall of 2021. So if you have any questions about this survey or the research, please contact the research team at the University of Windsor, who will be listed in the survey link, which will be provided in the chat for you to complete at your convenience. With that, I would like to welcome to come back to the panel and provide a little bit of context. Despite the increasing number of zero-emission vehicles purchased by transit agencies, the majority of buses in Canada are still diesel, which contributes to Canada's greenhouse gas emissions. New electric buses are a solution, but for many transit agencies, the cost of abandoning their diesel bus assets before their end of their life and buying new electric buses is just too expensive. So what if there was an alternative solution? Our panelists today are going to talk precisely about this solution of retrofitting diesel buses to electric buses. I would now like to welcome our panelists. First up, we have Gara Hay, who is the president of MTB Transit Solutions. We also have RK Hong, who is the CEO of Microgreen Solar Corporation. And I'd also like to welcome our last panelist, Mike Kilka, engineer at Mississauga Bus Group of Companies. Welcome to the stage.
Thank you.
Excellent. And so now we're going to be moving into our first presentation of the panel. And so I'm going to call on Gara Hay, and the floor is now yours.
Great. Thanks, Adriana. And thank you so much to Qtric for putting on this great presentation. We really appreciate it. Hi, everyone. My name is Gara Hay. I'm the president of MTB Transit Solutions in Milton. I'm very pleased to provide some information about our launch of our new service called ZEV Clean Power. So today I'm going to share some of the background information on MTB and explain and update our service. And the goal is to help transit authorities achieve GHG reduction goals sooner. If you were able to sit on our exhibitor presentation yesterday, sorry about that. If you were able to sit in our presentation yesterday, my presentation yesterday, this is a shorter version of that. And I also have a new video to show at the very end that you probably haven't seen before. So I'll get started. So just a little bit first about MTB. So MTB is Canada's leading repair, refurb, and now repower specialist. We've been in business since the mid-1970s, and we've worked on over 6,000 buses in our history. So we've worked on every make and model OEM you could imagine. We have a staff of about 70 people based in Milton. And most of them are skilled workers, over 55 skilled employees. So these are mechanics, painters, welders, body men, a really good long tenure. Our average experience in our staff is about 10 years. We have a beautiful facility. It's over 2 buildings. It's over 110,000 square feet. We have 60 bays. We're on 10 acres of land, so plenty of room for your buses to come in and be parked. And we can actually even do test drives in our own property. So we have a really great facility. We're ISO 9001 certified, so that to us illustrates our commitment to our quality work. Back as we started to see the industry moving away from diesel, we decided back in 2018 to say we wanted to participate. We were very excited to see the transit authorities were moving away from diesel to clean propulsion, and we wanted to be a part of it. So what we created was Canada's first diesel to battery electric bus conversion, and we called it ZEV Clean Power. And it's a service to support transit's goal to achieve GHG reduction goals, and we want to try to get you there sooner. So we've developed a diesel to electric demo bus with the support of NRCan IRAP Fund. The bus is near complete, and we're expected to have it done this summer. Now, the goal of this demo bus is to help MTV prove out the concept, for us to show this concept to our customers, and also for us to build out our supply chain. And here's the illustration of the process. So on the left, we remove the diesel components. So it's the diesel engine comes out, the transmission, the fuel tanks come out, the steering box comes out. That is pulled out of the diesel bus, and it's replaced with the clean power elements on the right side. So we add batteries, traction motor, the electric steering, regenerative braking system. And what's really important on this process is that we don't adjust the gross vehicle weight. So the gross vehicle weight maintains the same going from diesel to battery electric. And also the passenger capacity and the seat layout does not change one bit. So what really is, the bus comes in and after about 6 months, it goes out with cleaner propulsion and looking basically brand new, ready for a new life. There are significant benefits for transit authorities on this process. Now, for medium and large transit authorities, this program is geared to complement the new procurement process. So as you're buying new electric or hydrogen buses on your procurement stage, we're going to come in and clean up some of the older diesel buses that still have a lot of life in them. So as you're buying clean at the front end, we're going to try to clean up some of the older buses that you still have in your fleet. Maybe for a smaller transit agency, say if you have 20, 30, 40 buses, and you may not have the infrastructure or the commitment to convert over to electric or hydrogen, this could be a great process to introduce your fleet and your constituents to electric vehicles. So you can start very, very slowly. We feel this is a really great program to make it easier on your supply chain. Because you know the buses, so say it's a Nova or a New Flyer bus, your staff is well trained on the bus and you have parts of your inventory. So you're going to get that same bus back that you've always worked on over the years. It's just going to be powered differently. So the familiarity with both your drivers and your maintenance staff, and even your riders who are going to be on that bus, is going to be very consistent. One great element of our program is we have basically 100% of the capital cost to convert that bus will be recovered in lower operating costs for the remainder. So think about, you pay for the conversion up front, but your fuel costs will be dramatically lower and your maintenance will be dramatically lower. All the benefits that you're seeing from your new OEM electric buses, you'll see from this converted bus as well. So we have a very good environmental story to tell here, but the financial story is very strong as well that we can illustrate to you. There's very good funding available through Infrastructure Canada. We met with Catherine McKenna back before Christmas, which she endorsed this program and said there would be funding available. We also met with the Infrastructure Bank of Canada, who endorses repowering as a use of finance funds to help get the funding through for this program. And also, just as a side note, we're also working on a diesel to hydrogen fuel cell conversion. So if fuel cell is in your plans, we're starting to work through that supply chain and the elements, because I'm sure you know a lot of the work on converting an electric bus a lot of that work could be transferred over to a hydrogen fuel cell conversion. Here's just an update on our current demo bus. Some shots. The bus is just through the final stage of testing and bringing up the batteries. On the top left side, you'll see this is where about 40% of the batteries are placed on the roof. On the right side, those two pictures, this shows you where the diesel engine has come out and the new traction motor has been placed and there's been battery packs placed in. It looks very similar to a new OEM electric vehicle when you look at from the back end, showing where the traction motor and the batteries are placed. So that's it for me. So one thing I just wanted a few points as I finish. So we really believe strongly that ZEV program can provide great environmental and financial benefits to a transit operator. We're very confident in our ability, so we think that we know MTB has the people, the experience, the facility, and the commitment to make ZEV a great success. The one thing is we can repower buses in about 6 months, so we can do them quickly and very cost effectively. And again, the one last key point, just to remember that a lot of the savings from the financial side, a lot of the savings, or a lot of the costs to do the conversion will be saved in operating cost savings through the life of the bus. We have a much more detailed presentation. We dive deeper into the technical aspects of exactly the elements that will be coming out of the diesel bus and the new product, or the new components that will be going in on the electric side. And we have some really good financial modeling that we'd love to show you. So please reach out to me, Tom Glover, go through our website. We'd love to come out and do the presentation more detailed for you. So if I could just play the video now, that'd be great. There are very aggressive goals in place by many of the large transit operators to be greenhouse gas free by 2035, 2040, 2050. So the days of diesel buses is over. And whether it's battery electric or hydrogen or something new, we're not sure, but diesel is done. This is a new venture and a new avenue into the future of transit, and we're going to be a big part in that. The advantage is with the diesel powered, it always produces GHG gases into the air, but when you convert it to an electric powered bus, there are no more GHGs. So what we first do is we refurbish the entire bus to make it basically like brand new. And the key part of this conversion is at the back of the bus, we're going to then replace the motor, and I'll show you. So in the back of the bus, there is normally a large diesel engine that is right in here, and it takes up almost the entire area of the back of the bus. We're going to be able to take that diesel motor out and replace it with an electric motor that's about that big. So we replace the motor, and in here goes all of the batteries. So that'll then allow this bus to be propelled with battery electric instead of diesel. One of the key areas we're going to start working on is remodeling the entire bus. So as you can see, we've already installed the seats. The new flooring will come very soon. There'll be a great new paint job, including great graphics up on the sidewalls to make sure everybody knows that this is an electric powered bus now and how different it actually is. The driver area will be changed out from the old dial systems over to a new computer screen, so it'll really feel like it's a new modern sort of bus that's out there, not like the old bus that they've normally been using. So that bus leaves our shop looking brand new, but being propelled by clean energy. So ZEV means zero emission vehicle, and clean power is an important part of our name too. It doesn't say ZEV electric or ZEV battery. It's clean power because we also think we're going to be doing from diesel to hydrogen, diesel to maybe a new technology that we don't even know about right now. So right now we're doing diesel to electric because that is the hot transformation of the industry today. But as the industry transforms, we want to be ready to be able to support them at that as well.
Amazing. Thank you so much, Gara. It's really great to see all the work that you're doing at MTB and ZEV Clean Power. And I'm excited to hear more in our discussion part of the panel.
That's great. Thank you.
All right. So next up, we have RK Hong to present his presentation. And RK, the floor is yours. If you would like to just unmute yourself. There we go.
Can you hear me? Oh, sorry. So what I like to speak about is a Canadian battery solution for the diesel to electric retrofit. And this solution complements what Gara has presented for the diesel to electric conversion. So we focus on the dry battery part, which is a significant part of the EV supply chain. In less than 1 year, Canada and Ontario have made huge investment into the manufacturing of electric vehicles, and that definitely will drive the demand in the establishment for a supply chain for the EV sector. And battery pack is the immediate connection chain of the battery to the EV manufacturing. It represents a significant part of the weight in the cost for the entire electric vehicle, and we can arguably say that is the most critical step in the value chain because it integrates the innovation in lithium battery cells with software, communication, power electronics, and thermal management technology. The reliability of the battery, dry battery, has immediate impact upon the safety, performance, and therefore the ROI for the spending on the electric vehicle. So what we do is we import battery cells from overseas, and we manufacture into dry battery pack in Ontario. We have two processes. One is cell to module to pack, and the other process is the cell to pack. I will explain a little bit more about it. So the manufacturing of the dry battery pack will generate demand for the lithium battery, and presently we are using imported cells, and hopefully we can use the domestic lithium battery cells soon, because we have heard of many announcements to make manufacturing of the lithium battery in Canada. So putting the lithium battery manufacturing in our dry battery pack manufacturing together will bridge the entire supply chain from the minerals to electric vehicles to support the mine to mobility vision of Canada. Okay, so in addition to the high volume passenger EVs that are being built in Canada, we are confident that Canada will excel in a niche commercial electric vehicle generating volume demands for the dry battery, and of course also for the fuel cells, which I learned from the discussion today. The electric bus is a good example of that. For retrofit, the vehicle configuration is a constraint, is a given constraint. So we must deliver the battery drive to fit this physical constraint. In Canada, we are facing an extreme range of weather conditions that are presenting a tremendous challenge for a reliable battery solution. And because of the sensitivity to the temperature condition, it's not easy to deliver one universal battery solution for all regions across Canada. Driving range, road conditions, and the charging infrastructure are also impacting the design considerations. So to achieve all those criteria, our first step is to conduct a simulation, taking into all of the above factors to arrive at the optimal solution for the battery pack. And we license the simulation technologies from our partner, and the simulation tool has been successfully deployed worldwide. From the simulation, we can reliably estimate the performance profile of the dry battery in a specific environmental condition. So because the volume of retrofit is a relative volume, and our methodology is to customize and optimize the dry battery to fit the user case. Next, I will describe 3 examples of our battery pack. This is an example where we use the lithium battery cell of 228 amp-hour, and we put 48 of them together to create 154 volts, and putting 4 packs to create 610 volts. And we combine 3 streams to finally arrive at the energy capacity of 424 kilowatt hours. And because of the space consideration, these packs can install separately in different compartments of the vehicle, such as the bottom, the back, and the roof of the bus. Next example is a higher capacity battery for bigger vehicles, and we use a bigger cell, 302 amp-hour, and we put it in a different configuration. So the final configuration is a 525 kilowatt hour battery. Now, the 2 examples I have presented are using the cell-to-pack technology, which means we are producing the pack from the lithium battery cell in one monolithic step. And the form factor of the battery is prismatic. Third example is a completely different approach. We assemble cylindrical lithium battery into module and then produce modules into pack. So it is a cascaded process, and the process of manufacturing is very simple. We have far fewer components in the bills of material. The drawback is that it does not have the same level of energy density as the previous LFP, but this is not a big problem because of its fast charging characteristic, and the cost of the lithium, titanium oxide is 3 times higher than the cost of the LFP at the cell level. But very importantly, it offers advantage for us to tolerate, for the dry batteries pack to tolerate extreme cold weather conditions that we will encounter in Canada. Okay, so the technologies for battery packs evolve quite tremendously. 5 years ago, the process was highly modular, from cell to module to pack. Today, this cell to module pack coexists with the cell to pack methodology. In the cell to pack methodology, as I said earlier, the manufacturing process is monolithic, and we are moving, the industry is moving now into the next technology, this cell to chassis. That's everything in one step from cell to the chassis for the manufacturing of the electric vehicle. And this is likely in 10 to 15 years. Because of this progression in the technology and methodology of the dry battery pack, it offers us tremendous opportunity to bring innovations and technologies into the dry battery solution. Next is our methodology of creating a Canadian solution for the dry battery. Federal government and Ontario government are very strong advocates for the sustainability made in Canada and made in Ontario technology. So dry battery pack is a perfect example to accomplish of that. So we create this Canadian solution in 3 steps. First, we invest into the manufacturing and testing facility. Then we license the key technologies from established players so that we can go 1 step immediately into the qualification for the dry battery pack into the supply chain of the OEMs. Third, we form partnership with the Canadian research environment to bring the innovations into this supply chain. Under the QTRIC support of R&D to us, make collaborations of R&D with the University of Toronto and University of Waterloo, and we're expanding that to McMaster University and also in RC lab. So dry battery is a very high complexity. It involves hardware, software, and communications and thermal management technologies. Fortunately, the Canadian R&D community has the ability to handle all of that. To summarize, I like to point out that the retrofit offers a very fast way to remove the diesel bus from the road. Is a ready solution to go. And our goal of the Make in Canada dry battery will immediately will have the immediate connection to the EV manufacturing into the EV supply chain. Hopefully that will trigger the domestic manufacturing for other components of the dry battery. And putting those together, the battery manufacturing and the dry battery, the lithium cell manufacturing and the dry battery manufacturing will bridge Canada's vision for the mine to mobility in the transportation, and the dry battery pack solution coupling with the entire repowering solution that the other speakers are presenting, actually making a ready solution for the retrofit of diesel buses, and we are ready to go. Thank you.
Excellent. Thank you so much, RK. It's really great to hear how the work that you're doing with batteries definitely complements the fitting aspect of diesel to electric. All right. So next up, we do have Mike Pilka, who will be presenting next on Mississauga Best Group of Companies. All right, over to you, Mike.
Thank you, Adriana. Thank you, QTRIX, for opportunity to present here. And good morning, everyone. Today, I will talk about features and benefits of RetroMotion and Motion 2. I would like to start by introducing Mississauga Bus Group of Company and our partner e-Traction to the audience. Mississauga Bus was founded in 2002 by Raj Mahadeo. At this time, the primary focus was on rebuilding of engines and transmissions. Now, after more than 18 years, the business has expanded and has become more involved with new leading-edge technology and products to be offering for the transit industry. Mississauga Bus is member of a few industry organizations, including Qtrix. Our partner, e-Traction, was founded in 1981 in Netherlands. e-Traction is part of Evergrade Group. They developed and implemented the in-wheel pattern drivetrain technology. Could you please play the video?
Improvements to our transport systems are powered by technological advancement. Increasing the efficiency and economy of our vehicles is driving innovation forward as we enter the era where electric power achieves mainstream adoption. The traditional transfer of energy from engine to wheel is inefficient, noisy, and high maintenance. But what if there was a simple, quiet, and efficient way to power our vehicles that used a fraction of the space of conventional engines? Direct drive in-wheel motion technology substantially reduces energy losses by eliminating all gears and the majority of rotating parts. The unit provides power from battery to wheel at 94% efficiency, outperforming electric powertrain benchmarks by up to 15%. This in-wheel motor setup also reduces the number of moving parts, massively lowering operational maintenance costs, providing maximum driving comfort with minimal noise. This combination of factors gives e-Traction's tech one of the lowest total costs of ownership on the market. Enter e-Traction and their integrated technology platform that offers a revolution in motion. This system fundamentally simplifies drivetrain technology as the electric motor is housed within the wheel itself. e-Traction's unique smart control enables a number of innovative and performance-enhancing functions. Its smart software connects seamlessly with traditional ABS and EBS systems, allowing for an optimal brake blending strategy that boosts energy efficiency by optimal regeneration. High torque and power motors enable fitment to 12-metre and 18-metre buses as well as commercial vehicles. The innovative system, which combines wheel, motor and inverter all on the rear axle, works perfectly in new vehicles and can even be retrofitted into existing fleets. This, combined with a 94% efficiency, smart control, reduced total cost of ownership, zero emissions, full automotive compliancy and a wide scope of applications means the e-Traction system offers huge advantages. Efficient, reliable and accessible, the next generation of in-wheel motor technology is here. e-Traction is ready to drive innovation in transport forward once again.
Mike, you're on mute.
I'm sorry. There are many benefits of converting a diesel bus to electric bus. Low number of components resulting in low maintenance cost, need to replace only the bearings in the motor. No gears in the system resulting in low friction and high efficiency, and no oil to deal with. Retromotion is a complete system that includes other components beside the Motion 2.0. The other components are battery packs, battery management system, power steering, electric air compressor, electric HVAC, electronic programmable dashboard, battery cooling module, and also traction cooling modules. I would like to highlight here the direct drive efficiency up to 94% from battery to wheel. Of course, the efficiency varies based on a number of different factors, such as vehicle itinerary in service, driver behavior, season of operation, battery state of charge. The main components of the Motion 2.0 system is the axle. These are the subcomponents of the axle you have seen in the video. The control is an intelligent power control unit responsible for all driveline related functions. It controls the in-wheel motor and interacts with driver input, vehicle controllers, and energy system. The smart control functions enable efficiency and integration with other systems in the vehicle. The Connect is a specially developed PDU, power distribution unit, which is managed by the control and is part of the safety system of the motion. It provides the connection between high voltage DC supply and the in-wheel motors, containing all necessary function for high voltage distribution and protection in the in-wheel motor system. The motion tool is the software designed for diagnostic calibration of all components in the motion system. It contains fully functionality to support OEMs in integration, support field service with diagnostics, and even enables remote diagnostics. It is designed in compliance with all applicable standards and communicates via UDS and via J1939. The axle has been designed as a direct replacement of existing rear axle in transit buses. No structural modification needed to integrate the direct drive system into existing bus structure. The wheel assembly consists of a high power and high torque electric motor with permanent magnet, high power inverter associated with a smart software to control the motor, an end cover with disc brakes, waterproof seal to meet IP6K 9K, twin tire assembly. Also, the electric motor is very silent. The integrated high power drive features intelligent motor control, self-protection, diagnostic features, and communicates through CAN with the control unit. In case an unfortunate event that one of the motors fails, the bus can be driven back to the shop with one motor, no towing required. The subframe is the high-strength structure of the Motion 2.0 connecting the two motors. The subframe and the motor together, it forms a 13-ton driven axle. It is suitable for low floor bus application with an inside width of 822 millimeters. The diagnostic software supports all the motion components, features role-based authorization, complies with industry standards, provide remote diagnostic, calibration, software updates, and test procedure. Next slide shows the roof layout of one of the vehicles that has been converted. The next slide shows the layout, battery pack in the engine compartment in the left picture. In the middle picture, you have the inverters, converters, and power distribution box. And on the right picture, cooling modules on the roof, traction cooling modules, and battery. As part of conversion, we will replace the rooftop conventional AC unit with a rooftop electric AC unit with heat pump. This particular AC unit can generate heat up to minus 15 degrees Celsius, has two independent electric compressors that operates in two stages. In the event of one compressor failure, the second compressor can function and the vehicle doesn't have to be out of service. Coming soon, we are working on adding the fuel cell to our buses to extend the driving range. Together, we are changing the world with a new technology. Thank you very much for your time, and please contact us if you have any questions. Thank you.
Thank you very much, Mike. And I'd like to welcome back all of the panelists to the stage. We have tons of questions coming in, and it's really great to hear all the movement forward going on with retrofitting and batteries, and we're really excited to hear more. So the first question I'd like to ask for all the panelists today is, how does retrofitting assist Canada to move towards their 5,000 zero-emission bus goal by 2025? So we'll start with Gara.
Yeah, good question. I think, the great moves that most of the transit operators are making to start procuring new electric or hydrogen buses is awesome, but there's still probably approximately 15,000 diesel buses on the road, and many of them are new. I mean, we still see that there's current procurement going on for new diesel buses. So when you think about a diesel bus may have a 12 or 15 or 18-year life, there's going to be diesel buses in the marketplace well into the next decade. So, that's why we feel this program, and these diesel buses are still operable. They're great buses. They're well built, and it just doesn't make sense for us. We're hearing some transit operators saying that they may have to pull some of the diesel buses off the road earlier than their life expectancy so that they can hit their GHG targets, which we understand that, but we then say, hey, let's keep those buses on the road. Let's just repower them so they're not putting out GHG. We're looking at a cleaner propulsion.
Excellent. Yeah, and great to note that there are tons of diesel buses still on the road, and like you said, more being procured. So for those diesel buses still on the road, this is a great way to then transfer that to zero emission. Next, Mike, did you have comments on that?
I have to agree with Gara on this. There are lots of diesel buses right now, and they are very well built to last 15 to 18 years in service. And if these vehicles are brand new or in a range that can be retrofitted, there's a big opportunity for everybody to jump on that event.
Exactly. And RK?
I would just like to add 2 additional points. First is that the retrofit is a fast way to remove the emission out of the road, because the lead time for the supply of new electric bus may be longer. So this is a faster way. And the older diesel buses are the worst emitting vehicles. So you take out the worst emitting vehicles off the road. Third point I want to make is Gara has done a wonderful job to convince CIB to fund the diesel to electric conversion. And from a financial perspective, we believe the conversion part is the entire cost of conversion is feasible, is eligible for the funding. So for the transit agencies, they do not have to cost. There's no financial burden for them. So in the technology is ready. So we believe that is a good way to achieve the target of 5,000 electric transit buses by the next 2 years.
Wonderful. Thanks, RK. And that's a really great segue into one of the questions from the audience, which is, the federal government recently acknowledged the QTRIC Z Committee that they will fund the retrofits through its $2.75 billion zero-emission bus funding. And also thanks to Gara for advocating on that. So which transit agencies are moving in this direction in your view? Or are maybe school buses and school fleets a more likely low-hanging fruit here? So maybe we'll start with Mike.
Well, our product will fit all kinds of vehicles, including school buses and commercial vehicles. The rear axle can be fit in any of these and these vehicles. Right now, I believe that the funding that was put out for the federal government, we can use it in all kinds of transit agencies. They can use this funding to upgrade their fleet from diesel to electric.
Excellent. Yes, thank you, Mike. And Gara, did you have other comments on that?
Yeah, we've talked to several transit operators in Canada already about our project, and there's a lot of interest. So we're excited about that. On the school bus side, we're not sure. School buses are quite inexpensive, and they're almost disposable after a certain time. So I'm not sure a school bus operator would want to invest the capital to electrify a school bus when Again, the replacement value of a school bus is much cheaper than the replacement value of a transit bus. So not sure about school buses. We'll wait and see.
Okay, great. Thanks for those insights. Next question from the audience is from Terrence. How many years of life expectancy does repowering add to a diesel bus? And if I could add also on there, is there an expected payback period? Maybe I'll pass that back to Gara first.
Yeah, so we're seeing that it can extend the life of the bus from, say, 10 to 15 years. It all depends when you do the conversion, but our analysis shows that you can get basically a lot of extension on that. And as far as the payback goes, it's about an 8 or 9 year payback. So think about if you can extend the life by 12 or 13 years and it's paid back after 8 years, then there's positive net payback on the project.
Excellent. And Mike, did you have anything to add on that?
Yeah, I can say that there are many buses out there, but if you're looking into converting a vehicle from diesel to electric, don't go with a 15 years old vehicle for conversion, because will not help.
Okay, great. Thanks for those insights. Next question from the audience is from Aaron Cook. This is back to Mike. Heat pumps do not work in cold climates. Is the heat pump just for AC with an alternative option for heating? And I noticed that you had mentioned it was for heating in negative 15 degrees Celsius weather, but a lot of Canadian cities get a little colder than that during the winter. Do you have any comments there?
Yes, the heat pump is part of the AC unit, and this particular one works up to minus 15 degrees Celsius, creating heat. And if we go below that 15 degrees Celsius, we can use auxiliary heaters for this, even electric or diesel or hybrids.
Okay, thank you, Mike. I'll go back to another question here. One question actually I had when listening to all your presentations was about the charging capabilities. Is the charging for the retrofitted buses only plug-in, or is there pantograph capabilities, and what are some of the range considerations? Maybe we'll start with Gara.
Sure. Yeah. So our demo bus, it's we're doing in-depot charging only on our first project. It's J1772 compatible. So we wanted to make sure that you wouldn't have to bring in unique equipment to charge our bus. We want to be able the transit operator to be able to use the charging equipment that they have. So it is compatible. As far as pentagram, we think a lot of the work we've done, we can then now extend that into a pantograph demo coming up. We just picked one. We thought the in-depot, obviously the in-depot is the most widely used charging method right now, so that's why we stuck with that. But we think as we start moving forward, we're going to look at, if the transit's interested, we can look at doing the pantograph as well.
Excellent. And RK, did you have a comment on there too?
Well, my only comment from the perspective of dry battery is that the range is linearly and directly related to the energy density we can put on the drive battery. And that has a lot of correlations to the environmental condition, to the driving profile of everything. So the proper and the optimal design of the dry battery would actually have a significant impact on the drive range.
Excellent. And Mike, did you have any words on the charging capabilities?
At this point, we are using in-depot chargers for our systems. But of course, as Gaurav mentioned as well, we have to see where the transit authorities are looking in which direction. If they have the infrastructure to use the pantograph, we can move into the direction as well. But right now, we're offering depot chargers.
Okay, wonderful. I do have a question from the audience from Terrence for RK. Is it worth repowering a CNG bus to EV?
Oh, well, from the dry battery perspective, everything can be repowered. So it's a matter of economics, in the matter of the compartmental space available to house the battery. Now, to answer the question properly, we will need to conduct the simulation on what is the compartmental space available and what is the expected driving profile, the anticipated road condition, and the availability of charging infrastructure, putting all of them together can give suggestion for the feasibility and the practical ability to implement a proper solution.
Excellent. All right. So our next question, we have so many coming from the audience right now. This one is from Maurice. Are you Gara and perhaps even Mike? Are you considering a demo for a smaller unit, for example, maybe a shuttle or a minibus? And also, are you doing retrofits for smaller units? Oh, sorry, that's the same question. So for the smaller unit.
Right now we're just looking at the 40-foot, and we'll probably look at a 60-foot next, just because that's the the most widely used bus format in Canada. So we're going to focus on those. But a 30-foot would be interesting because a lot of the same engineering work that we've done on the 40-foot, we could probably bring down to a 30-foot. To look at a cutaway, possibly, but just not on our radar at this point. But let's get the 40-foot on the road and functioning, and then we're going to start looking at expanding it to other sizes after that.
And Mike, are you also considering any minibuses or?
I will say the same thing. 30-foot is feasible. Cutaway is not too much room to install the batteries. Even on the 30-footer, the batteries, it's going to be a limited volume of battery and storage capacity on those ones, and the range is going to be lower than the 40-footer bus.
Yeah, Adrian, if I could just add, I think as the battery technology improves, so we're going to be able to get a lot more range out of a smaller battery, then that will probably open up the opportunities to smaller. But like Mike said, if to try to jam the current battery structure into a smaller bus it's going to be tricky right now.
All right. So next question I have from Yannick, and this is for RK and Gara. What efforts do you make to design for thermal control of the batteries to ensure longevity and propagation mitigation? So RK, we'll start with you.
Well, thermal management, thermal control is probably the single most critical factor that impacts the safety consideration in terms of what we do. And that is the Canadian R&D community has a very rich wealth of experience in the thermal management. University of Toronto has the technology, University of Calgary, the NRC lab in Ottawa, NRC lab in Vancouver. So, and also McMaster University. So we're working with all of them to commercialize their innovation. And that is the part where I believe Canada has to have a very specialty solution, because we are facing extreme weather conditions that makes the thermal management a very sophisticated and very important factor in the design of the electric battery. So that is the technology that Canada has strength, and is certainly one direction that focus in investment in.
Absolutely, yes. And in Canadian climate, it's a very important issue, and it's great work that you're doing there. Gara?
Yeah, on our demo bus, our batteries are thermal cooled or liquid cooled, and obviously, we're going to make sure that they have the proper constraints that are needed to operate in all of our different climates. So, one thing we do is we have a much more detailed presentation that we can give when we get into. We spend probably 75% of our presentation on the technical aspects of our conversion, and within that 75%, most of the discussion is around the batteries, on how they're maintained, how they're managed. I don't want to get too technical right now, but we have more technical information than you probably need. So we'd love to show that.
Excellent. All right. So maybe shifting gears now to cost. We have a question from the audience here on or cost and economy. How might retrofitting benefit the economy and create jobs? Maybe we'll go to Mike first.
Well, of course, when you have to retrofit one of the vehicle, you need certain components to retrofit. So you have to create a chain supply for the parts, and also to have technicians able to switch from diesel to electric, to be able to do the installation of these components, which are mostly electric components. And also to service those buses later on, which servicing is less than for a diesel bus. So all this creates new jobs, and put a I don't want to say that put pressure on some of the companies to train their technicians in the electrical field, which they have to do it anyway if they're going to buy brand new electric buses.
Yeah,
and we're here to service those.
All right, thank you very much, Mike. I actually wanted to pass the question over to RK. RK, are you okay to take the question of, because I heard you talk about collaboration and R&D, and so I'd like to hear more about how this will contribute to that.
In terms of contribution to job creation in Canada from the perspective of the dry battery, let me just note that all of the manufacturers of electric bus in Canada are bringing dry battery from overseas because there isn't any in Canada. So if we were to set up proceed to domestic manufacturing of dry battery in Canada, that is a direct and immediate job creation in Canada. Second point I want to make is that dry battery is the piece into the in the last point of connection, the direct point of connection with the EV manufacturing. And it brings all of the technology, like thermal management, battery management, power electronics, software and hardware together. So it has the ability to create fair amount of derivative job creations in the rest of the supply chain for the EV sector.
Excellent. Yeah, a lot of opportunities for manufacturing here.
And it also creates the opportunity for the R&D collaboration with all of the institutions across Canada, and that is creating jobs in the research and development space.
And training for high quality personnel. Excellent. Another question about cost is what is the typical cost range for conversion? So I'll pass it over to Gara first.
Also, if I could just go back to the previous question, I just wanted to, if you're okay, one thing that we're very proud of is that when we started building out the supply chain for this new effort, we quickly realized how strong Canada was from a supply chain and expertise. So, when you look at our demo bus and our project, our engineering and our traction motors are from Quebec, and all the assembly work, our telematics, our batteries, and all our testing is done in Ontario. And we're very proud of that. And when I made the presentation to Minister McKenna before Christmas, that was this. We had the slide that showed the map of Canada and where all our inputs are coming from. And she loved it. And she every time I started talking about something else, she'd kind of go back to that slide again and how excited she was that we're able to supply companies like ourselves with all the inputs that we need, which is really, really terrific. Sorry, on the cost side, on the price side, it varies because until we look at the spec of exactly what the transit operator from, what's the OEM of the bus, the age of the bus, and how much range are you looking for? There's many variables that drive the final pricing for a conversion. So, I really can't give you a number right now because, again, you need those specs. But we can get that pricing very quickly once we find out exactly what the goals of the transit operators are and what we're going to be working with before we can really give that proper price.
Yeah, that's an important piece too, like the age of the bus and everything to take a look at.
Right.
All right, excellent. I do have a question, Mike. You mentioned about training of staff with the electric pieces on there. Many new electric buses require driver retraining on electric operations and new maintenance training. How does a retrofitted bus compare? Maybe we'll start with you, Mike.
A retrofit bus from diesel to electric has to have, in the end, is going to look like an electric bus, brand new electric bus. So the driver has to be retrained how to operate those buses. Acceleration will be different. Gradability will be different. They have to be a little bit easy on the throttle to be able to maintain a long range for these buses, because it's not like a diesel when you when you accelerate very fast, and you will not see a difference on the fuel consumption directly, but on electrical vehicle, you will see that the driving range will decrease if the driver's behavior is not getting to an upper level, so they can perform better.
Excellent. Okay. And Gara, I think I saw in your presentation that retrofitting the buses is more familiar for the drivers. Did you want to comment on that?
Yeah, no, that's great. Yes, I mean, we think, just think about that driver. He or she have been driving maybe a Nova or a New Flyer for years, and they're going to then get in the bus a new time, and it's going to feel the same way. It's going to look the same way. It is, as Mike said, it is going to handle differently, but probably better. It's going to be quieter for one thing, but they're used to the surroundings of that bus, and we think that's important for that driver to feel really comfortable with that, with the surroundings. The seat's the same, the steering wheel's the same, so kind of the ergonomics are not going to change, but the bus is going to handle better and quieter, and also for the rider. So the transit driver, or the person who's been on those buses for years, they're now going to get on that same looking bus, but it's going to all of a sudden be clean and quiet, and when it pulls away from the curb, it's not going to spew out black smoke and make a bunch of rattling noises. So we think that familiarity with both the driver and the rider is a real huge benefit of this.
Excellent. And so we don't have too much time left, so I'll try to fit in a few more questions. Another question from the audience is, what about warranties that manufacturers usually offer to transit agencies? If the retrofit experience an operation challenge, how would you address it? And so maybe we'll start with RK.
Well, the warranty for the battery itself is very simple. So for practical approach, we have lithium battery pack in our warehouse. So when it breaks, we have the ability to swap and replace, and then we handle the repair and maintenance in our back office.
Okay, perfect. And maybe we'll pass it over to Mike.
Approach to deliver a smooth operation for the transit operators.
And Mike, did you want to add on to that?
We can, of course, we offer warranty for all the components the brand new components that we put them in the bus. The warranty on the vehicle itself and structural part, if we're going to do the retrofit and we're going to upgrade the vehicle, at that point we offer warranty on that one. But every component comes with different warranty, and we are here to support the transit agency with repairs and warranty as well.
And let me also add is, in our simulation, we conduct the ability of the battery to operate on road. So out of the simulation process, we'll come up with a specialized warranty program. And that warranty program will tailor-made to the different environmental conditions in driving range profile. So we are trying to stretch the warranty to maximize the drive range and maximize the return on investment for the spending on the EV. Yeah.
Okay. And then hopefully we can fit in a few more questions, but one from Aaron Cook is, what sort of structural validation of retrofits can be completed? For example, at Winnipeg Transit, their midlife overhaul typically extends the bus by 9 years. Gara, did you want to answer that question?
Yeah, so, well, first of all, I'm not sure I quite understand, but, one thing, our engineering group that's working on this, they understand the impact that putting batteries around the bus has. So that has engineering sign off before we do any of the work. So there's, the transit can feel comfortable that where we're placing the batteries and throughout the bus has been signed off from a structural standpoint. And again, we're hoping to extend the life by 5, 7, 8 years from maybe where it was normally going to have an end of life. So obviously we have to take that into consideration, make sure that the body structure will be able to last as long as we're expecting it to be on the road.
Wonderful. All right, we are wrapping up to the end of the session. So I did want to have one last question. What would be your last 30-second takeaway or advice to transit agencies who are thinking about going electric or retrofitting? We'll start with Mike.
I will say that there are enough buses out there And if you're not sure what to do, just pick up one or two and do two different tryouts and compare the vehicles on the road, compare it if they work for your transit agency, and go in either direction.
Great. Yeah. So what I'm hearing is try different things and just go for it. All right.
Yes.
RK?
Well, my advice would be to conduct a simulation on the specific configuration of the vehicle to understand the economic return, to understand the remaining life for the retrofit. That would be a practical starting step.
Fantastic. Yeah. So simulation and data is very important in the beginning when talking about these types of things. And then Gara, any last words there?
Yeah, it's kind of similar to what Mike had said, but the timing is right now. The money is available, and the funding and financing from the government and Infrastructure Bank Canada is there right now. So let's jump on it while the iron's hot. And I really encourage you to reach out to us and let's do a presentation. And our presentation is it's light on the salesy side, but it's really heavy on technical and the financial payback. So we think you'd be. I think that it would be a good use of an hour of your time to go through the program and let's get moving.
Wonderful. Yeah, I'm hearing taking advantage of the funding that's going to be available quite soon. And if anyone out there is interested, reach out to everyone on the panel. We have their information, and so we will be able to share that with you. So this was a really great conversation. Thank you so much, Gara, Mike, and RK for taking the time to come to the panel today. And thank you to the audience for attending this session. I'd like to encourage everyone to attend the networking session, which is at 2:45 p.m. Eastern Time. Hopefully you'll get a chance to speak with some of our panelists today. But if you can't attend, you can also network with each other by following the attendees using the networking portal on the conference website. So that's just at the top. It's called networking, where you can message each other one-on-one and exchange contact information there. So thank you very much, everyone, again, and hope to see you at the next session. Thank you.
Thank you.
Thank you, everyone.